Okay, this is 7.5, scatter plot predictions and inferences. All we're going to do is we're going to have some scatter plots and we're going to make predictions, as the title says. This is how it goes. Predict what will happen if the student gets 11 hours of sleep. Well, on the chart there is no 11, so we're just going to go out and pretend 11 is right there. Now, you go to the number, you go up to the line of best fit. Our line of best fit will have to stretch. And then you go over from the line of best fit, you go over to sorry, I ran out of battery. From the line of best fit, you need to go over, make it as straight as possible, to where it would be on the y-axis. This is your x-axis, this is your y-axis. Well, it's probably going to be somewhere around 100 on your y-axis. You could say it's over 100, but history grade in relation to hours slept. Your grade can't be over 100%. I know you're saying extra credit, but we don't know about that, so we're just going to say 100%. Could you have said 95%? Yes, it's a prediction. So anything, I would accept anything between 95 and 100%. Okay? Now, using a line of best fit, that means if there's not a line of best fit, you're going to want to put one in. And if the line of best fit doesn't extend to where you need it to be, you'll need to extend it. That's not very straight, but we're just making predictions. Using the line of best fit, predict what the test grades will be with 2 hours of sleep. So I go to 2 hours right here, and then I go up until I hit the line of best fit. And then once I hit the line of best fit, I go over. Well, my pen doesn't really do it very nice, but it's actually just below 50. I would call that about 45. Anything between 45% and 50% would be acceptable. Remember, it's just a prediction. 1 hour of sleep, same thing. Go up, hit the line of best fit, go over. That looks like about 40%. Okay? That's all we're doing. All right? This one's exactly the same. Here, this is different. Here, we want to know what will happen in year 11. Now, on this one, it's a little different. They don't want you to guess the number of enrolled. They want you to tell what's happening between the reading class and the math class. Okay? So, what's happening is both classes will continue to increase. You can see right here how they're increasing. So both classes will continue to increase. However, is one of them increasing faster than the other? Yeah, math is increasing faster than reading. So both classes will continue to increase. Math will increase faster than reading. That's what I would say. Okay? Sorry I didn't write that down. My pen isn't working. I'll just go ahead and say it again. Both classes will continue to increase. Math class will increase faster than reading. This one, there is no line of best fit, so I'm going to go ahead and draw a line of best fit. And then I'll make my predictions. The age of a person who does 4 push-ups, number of push-ups is down here. 4 is about right here, so I'll go up till I hit my line of best fit. Looks like about 20 years old. Up. And then over. So it looks like about 20 years old. Predict how many push-ups a 70-year-old would do. Here, I'm going to go from the y-axis till I hit the line of best fit. And then once I hit the line of best fit, I'm going to go down. I would say maybe 12 or 14. So I'll say 13. Okay? This is exactly like the other one. As you can tell, we're talking about two different enrollments into 8th hour. The freshmen and the sophomores enrolled in 8th hour. Okay? So they both continue to increase. They both continue to increase. You can see they're going up. However, the sophomores are increasing faster than the freshmen. So that's what I would say. Both continue to increase. Both enrollments continue to increase. However, the sophomores increase faster than the freshmen. All right, this is your review. I would like to go over a few of the review questions. Especially number one. Number one, the important thing here is you have something outside of the absolute value.
Attention all JV basketball players. Your practice today will...
So because that is outside of the absolute value, you have to get rid of that first, okay? So I'm going to subtract 6 from both sides. Now, that cancels this out, leaving me the absolute value of 4x equals 22 minus 6 is going to be, was that 17? Sorry, 16. That'll be 16. This is my absolute value right here. That's what this is. It's not 14. I wrote my absolute value right here. Okay. So now I have the absolute value of 4x equals 16. So now I go 4x equals 16. And 4x equals negative 16. Now, I divide both sides by 4. X equals 4. X equals negative 4. Because right here I'm going to divide this by 4. Negative 16 divided by 4 is negative 4. These are your two answers. So when something is outside of your absolute value, you have to get rid of it first before you set it equal to the positive and negative answer. Number 3, nothing's outside of my absolute value. So on number 3, I just go 3x plus 4 equals 10. 3x plus 4 equals negative 10. Subtract 4. 3x equals 6. Subtract 4. 3x equals negative 14. Divide by 3, x equals 2. Okay, divide by 3. X equals negative 14 over 3. Okay? Those are the two different kinds. Something's outside of the absolute value, have to get rid of it first, then set it equal to the positive and the negative. Nothing's outside the absolute value, take that out, set it equal to the positive and the negative. Okay, we should be able to do this. All right. Thank you. Have a good day. If you have any questions, please come in and ask.